Here's our last construction. That's inscribing squares in a circle, and you have this in your notes. We're going to start with the given circles, center O. In the circle, center point, our center point is going to be given. Either I will give you the center point, or if you draw the circle, you'll be able to see the center point. And I'm really careful when I draw my circle that I've got some way to mark where my center is. We're going to mark a point A on the circle. This will become one of the vertices of the square. And like the inscribed hexagon construction, doesn't matter where you draw this point. Just draw it somewhere on the circle. All right, you're going to draw a diameter from that point through the center and cross the circle again. All right, you know that has to be a diameter because it's intersecting the center of the circle and 2 points on the circle. Just like we did in the equilateral triangle construction. You're going to set your compass on A and set the width to a little more than the distance to O. It has to be longer than the radius. Otherwise, when we're going to construct some arcs, and the arcs will not intersect if we don't make sure that the spread of that compass is larger than the radius. And you're going to draw an arc above and below. Now, just looking at that step, does this construction look a little familiar? Have we seen something before where we had a line segment, and a diameter is a line segment, and drew an arc above and below? And then moved the compass and drew an arc above and below again. Our last step, we're going to draw, well, not our last step, we're almost our last step. We're going to draw a line where the arc pairs cross, making it long enough to touch the circle at top and bottom, creating new points B and D. Notice that the line is going through the center, so it is a diameter. Now, not only is it a diameter, because there's an infinite number of diameters we could have drawn. That diameter is special, right? Think about what kind of construction is, right? The diameter is going to be perpendicular. What we did is we made perpendicular bisector. And a perpendicular bisector is key to this construction because there is a characteristic of all squares that you're going to learn right now. All right, so our last step in doing the construction, right, is to connect the vertices that are on the circle. So connecting points A to B, B to C, and C to D with a straight edge. This is guaranteed to be a square. All right, you try to measure 90 degrees, and I guarantee you're probably not going to have 90 degrees, and you're not going to have congruent sides. It's going to look kind of like it, but kind of like it's not good enough. And actually, when they're constructing anything where they need rectangles and squares, right, they're using this exact same method. They're making sure they have perpendicular diagonals. If they have perpendicular diagonals, they're guaranteed to have, and they have a quadrilateral, you're guaranteed to have a rectangle. If you have congruent diagonals, you're guaranteed to have a rectangle. If those diagonals are not just congruent but perpendicular, you're guaranteed to have a square. So we made sure our diagonals are congruent and perpendicular, right, to ensure we have a square. Right? So I'm not sure if I have this in your notes or not because I don't have it handy. Make sure this is in your notes, all right? And let's read it together, all right? So just a little reminder, some symbols there. That upside down T means perpendicular, and then we have the equals with the squiggle. That means congruent, right? So the equals means same measure. The squiggle means similar or same size. And a property of squares, right? And you'll need to know this all throughout the year. So squares have two congruent, and though this little mark here, which students sometimes have trouble reading, is and. You can put an and there if you can't, if you weren't sure what that was. And perpendicular diagonals. We used a perpendicular segment bisector to construct our square. Both diagonals are diameters of the circle. Right? So our diagonals are diameters of the circle because we made sure that those diagonals were perpendicular and congruent. Right? We ensured that this is a square. Well, how do we know they're congruent? Well, let's add this to the notes. That's how we know they're congruent. Just like all radii of a circle are congruent, all diagonals of a circle are congruent. Right? So that's how we know that the diagonals are congruent. They're perpendicular because we did a perpendicular perpendicular bisector. All right, let's go through those steps. All right, so example of the square construction. I'm going to go through this with you. All right, so the first thing I need is a circle, and I'm going to center my circle right here at that blue dot, because if I don't do that, I have, oops, wrong one. I have, no, I want a circle, not a, there we go. I have no way, see how my center's right at that circle? Right at the dot I drew? That's not making it too big. And then I let go, there goes the center of my circle. All right, so that's why I have to make sure I draw a dot first, or sometimes I use the compass point to mark my center. All right, so now I'm going to draw any point on my circle. Here we go, A. All right. And I'm going to use my line tool. You'll use a ruler. And so, oh, look at that, it's still green. I am going to make sure, right, that it goes through our center. Let's call our center O. Actually, I was using green. I guess I'll stay with green. All right, so this is O. All right, and then we have point A. Right, and then on the other side, we point B. So we know that, that's a little funky there. We know that that is a diameter because it has two endpoints on the circle, and it goes through the center of the circle. All right, so there is my diameter, which is now going to be the diagonal to my square. All right, so I'm going to open up and I'm going to use some other color, not green. Red, make it Christmassy. All right, so I'm going to make sure that it is open more than halfway, more than the length of the radius. That's fine. Probably doesn't have to be quite that much, but actually I'll close it just a teeny bit. There we go. All right, so now I'm going to make, I have the compass point at A, made an arc above, or I don't know if you want to consider that left, and below or right. Right? I've made arcs, and actually I better make these a little bit larger because when I move the compass it's got to intersect. So I'm going to make this a little larger. So it's easier for me to just go back over it again because the compass won't change unless I do something. Make sure you make your arcs big enough because you want to make sure when you move it to B that the arcs intersect. Otherwise you got to redo it a little bit. All right, there we go. How am I? Ah, so close. So close, but not quite. So, like I said, now I have to redo that arc. And it's a little easier for me. So just make sure your arcs are large enough. Oh, I think I'm slightly off when I put that arc in there. Either the first time or the second time. Let's try that again. All right, that one is good. And there goes the bad one. All right, so now we'll move it to point B. And now I'm sure it's going to go through. There we go. Right. Make the arc on either side again. And they are intersecting, which is nice. Because now I'm going to draw my diagonal. And I think it'll still be green. All right, so I'm going to draw it so that it intersects my lines. It's going to intersect the intersection of the arcs as well as the center of the circle and the edge of the circle. All right, so now let's mark those points. Here we have, we'll call that one C. We'll call that one D. All right, and I'm going to use some other color for my line tool. Oops, can't see any other colors. Oh, there, I think I'll make that black. Just so that I'm not looking at all green lines. There we go. And now I'm just going to connect A, B, C, and D which are the vertices of my square. And that's all it is to it, our construction. Although it would help if I made my lines long enough. There, I think that looks good. All right, so we're guaranteed that this is a square. Just tilt it a little bit, and that doesn't matter because we know that our diagonals are perpendicular. Right, so AB is congruent to CD, segment AB is congruent to segment CD, and segment AB is, perpendicular is what I meant to write, perpendicular to CD, segment CD. Therefore, this is the symbol for therefore, A, B, C, D is a square. Right? We've got a quadrilateral, right, where the diagonals are, and A, B, and C, D are diagonals. Okay, I should put that in there. So A, B, and C, D are diagonals. And so because those diagonals are perpendicular and congruent, and this is a four-sided figure, ABCD has to be a square. All right, thanks for watching, and bye for now.